Picture this. You're sitting in the exam hall. You flip the page and boom, staring right back at you is one of those notoriously tricky number conversion questions. Now, you know the math, right? You confidently jot down the correct final answer. But then results day rolls around and wait, you've lost guaranteed marks? How does that even happen? Well, it's because getting the right answer isn't always enough to satisfy the marks scheme. In this explainer, we're going to fix that exact problem, and we'll do it by mastering binary to hexadecimal conversion using Nibbles.
Think of it like a scenario with 3 doors, representing 3 students who just attempted this exact conversion. Student 1 tries to calculate the whole thing in their head and just writes down a single final number. Student 2 converts the denary straight to hexadecimal using division and remainders. And then there's Student 3, who uses an intermediate bridge. Spoiler alert, only one of these strategies actually unlocks full Cambridge exam marks.
So let's look at the stark contrast in what examiners actually want to see. On the left here, we've got a flawed, generic final answer. Sure, it might be mathematically correct, but it completely skips the working out. On the right, though, we have a complete answer. It deliberately shows those intermediate binary steps. And this, right here, is exactly where those crucial marks are won and lost. You see, you aren't just being tested on the destination. They really want to see the journey.
Section 1. Mastering the Nibble table, the foundation of conversions. Let's get right into it.
All right, let's lock in this definition with total precision. A nibble is simply a 4-bit binary number. That's literally it. Just 4 zeros or ones. Now, when you take 2 of these 4-bit nibbles and snap them together side by side, you create an 8-bit binary number, which, as you probably already know, is called a byte. The nibble really is your secret weapon here. Think of it as the crucial, perfectly sized bridge between our everyday denary numbers and computer hexadecimal numbers.
Now, this table is basically your ultimate 16-row exam cheat code. Notice how the denary numbers 0 through 9 perfectly mirror the hexadecimal digits 0 through 9. Simple enough, right? But watch what happens from denary 10 to 15. Hexadecimal suddenly shifts to letters, A, B, C, D, E, and F. Meanwhile, that binary column gives us every single 4-bit combination, starting from 0000 all the way down to 1111. Committing the mechanics of the simple framework to memory? Honestly, it makes everything else we're going to talk about incredibly straightforward.
Moving on to Section 2, Decenary to Hexadecimal Conversion, the upward climb. Now, converting from denary to hexadecimal can definitely feel a bit overwhelming at first. But before we get into the actual steps, I want you to keep this in the back of your mind. In just a moment, I'm going to show you the exact examiner clue that changes your final answer completely. Seriously, it's this hidden detail you absolutely need for full marks. But actually, scratch that. To even spot the trap, we really need to understand the core mechanics first.
So let's build a totally foolproof visual method. Step 1, we take our starting decenary number and convert it into an 8-bit binary sequence. Step 2, we literally draw a line right down the middle, splitting that 8-bit sequence into 2 4-bit nibbles. And step 3, we consult our handy framework table and convert each of those 4-bit nibbles into a single hexadecimal digit.
Okay, let's lock this in with a quick win. Take the denary number 16. First, we write it out as an 8-bit binary number, which gives us 0001 space 0000. Next, we split it right down the middle into 2 nibbles. That left nibble is 0001. If you picture your mental table, that equals 1 in hex. The right nibble is 0000, which is just 0 in hex. Pop them side by side, and boom, you get a hexadecimal value of 10. The main takeaway here is how effortlessly 16 in denary translates to 10 in hexadecimal using this exact bridge.
Which brings us to Section 3, hexadecimal back to denary, reversing the process.
To reverse the calculation, we're basically just running that mark scheme approved mechanism in reverse. Step 1, separate the hexadecimal digits. Step 2, convert each single digit back into its 4-bit binary nibble. Step 3, stitch those 2 nibbles back together to form a full 8-bit number. And then finally, Step 4, just use standard binary place values to add it all up into a final decenary total.
Let's visually map this out using the hexadecimal number 3C. First off, we split 3C into a 3 and a C. Checking back with our table, we know that hex digit 3 is 0011 in binary, and hex digit C, well, that represents denary 12, which gives us 1100 in binary. Now, we just snap them back together side by side. So our combined 8-bit byte becomes 00111100.
Now for the math part. We lay that combined binary string 00111100 right underneath our standard 8-bit place values. Working right to left, you already know the drill: 1, 2, 4, 8, 16, 32, 64, and 128. We just need to spot where our ones are sitting. We've got active bits under the 32, the 16, the 8, and the 4. Add those up. 32 plus 16 plus 8 plus 4 gives us exactly 60. And there you have it. You've just perfectly proven that hexadecimal 3C equals denary 60.
Section 4. Winning the mark scheme. The open loop closure. Now remember that examiner clue I mentioned earlier? Pay really close attention to the exact wording here. When an exam command word says calculate or show, you must show the intermediate binary working out to earn full marks. This is the massive trap. If you just write down the final hex or denary answer, even if it is literally 100% correct, you are not getting full marks. Skipping that intermediate binary nibble step in your written answer is hands down the fastest way to lose guaranteed points. The examiner desperately needs to see those nibbles to prove you actually understand the process.
Section 5. The interactive challenge. Pause and solve.
All right, here is a quick challenge for you. I want you to convert the denary number 75 into hexadecimal. I highly recommend you just pause right here, grab a scrap of paper, and calculate the conversion using the exact nibble strategy we've been talking about. Think about the 8-bit binary, then the split, and finally the hex translation. Okay, you got your answer? Let's check it.
Imagine me swooping in with a red grading pen for a rapid correction here. Step 1, you convert denary 75 to an 8-bit binary number, which gives you 0101011. Step 2, split it right down the middle into 2 nibbles. That gives you 0100 on the left and 1011 on the right. Step 3, use the table. 0100 is 4. 1011 is 11 in denary, which translates to B in hex. So the absolute perfect mark scheme approved final answer is 4B, with all that beautiful working out clearly shown.
So look at that. You have completely mastered the mechanics of these conversions. You know the framework, and you know how to avoid the calculate command trap. But there's a next logical problem you're going to face. Knowing the math is really only half the battle. Knowing the specific, repeating mistakes that examiners complain about every single year, that's the other half.
And to make sure you never miss the strategies that actually get you top grades, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations.
We've spent this whole explainer mastering conversions. But you know what? Learning this math is entirely useless if you walk into the exam hall and fall for the devastating traps waiting in the wording of the questions themselves. In our next explainer, we're opening door number 2, surviving examiner traps. We're going to analyze actual examiner reports to see exactly where students who completely know the math still manage to drop whole letter grades. You've got the shield now, but you still need the map. Click on the next explainer on screen to secure those remaining marks. Because honestly, if you don't know what the examiner is secretly looking for, are you truly prepared to ace the test?